1993 mechanics multiple choice, problem number 35. And usually by the time you get to this one, you guys want to stop? Stop. Listen. So we want to figure out what's going on here. This one does give people a lot of problems. So you've got a rod of negligible mass is pivoted at a point that is off-center so that L1 is different from L2. The length above show two cases in which the masses are suspended from the ends of the rod. In each case, the unknown mass M is balanced by a mass M1 or M2 so that the rod remains horizontal. What is the value of M in terms of the known masses? Okay, now this is a torque problem. So let's take a look at this. I've got mg like this, and I've got m1g, and I've got L1 and L2. So the torque, this force is trying to make this thing twist counterclockwise. And this thing is trying to make, M1 is trying to make it twist the other way. So therefore, but it's in balance. So this torque equals this torque. So I'm just going to go mg L1 equals m1g L2. So this gives me an equation. Now looking at the other one, and just to save time here, I'm just going to, rather than redraw this, I'm going to take a look at this. This is M2 G L1 is equal to mg L2. So this twist is going to be equal to this twist. And so now, first of all, we can forget about gravity because it cancels out of everything. And what do I want to solve for? I want to solve for M. So what I'm going to do is let's just solve for M2 right here, and then I'm going to, or wait, what? Yeah, I'm going to solve for L1, and then I'm going to plug it in here. So L1 is equal to ML2 over M2. And now I'm going to plug this in here. Am I still on screen? Yeah. So I have ML1, which is ML2 over M2, is equal to M1L2. So the L's2's cancel, and I've got M squared over M2 is equal to M1. So I'm going to multiply both sides by M2, and then I'll take the square root. So M is equal to the square root of M1, M2, which is E. So the big picture here is torque. That torque, if torque is equal to 0, then you have torque 1 and equals torque 2 going the other way, and then the torque is the force times the length, or R. Well, actually, use R cross. Start with R cross F in your mind, and then go from there. And notice that the angle is 90 degrees. So when you do that cross product, you can ignore the cross product. Look for that. If you have a basic equation that's a cross product, but the two vectors are 90 degrees to each other, and then you just ignore that cross product, and you just use the force times the length will get you the torque. All right. Is this clear? Sort of?
Yeah.
All right. You got it? Excellent. That is all.